In this video, we're going to continue looking at some fundamental counting ideas and look at two very specific situations with some known formulas and ideas for how to do that counting. The first is called a permutation. A permutation is just any arrangement of a group of objects with a definite order. Meaning you can tell not only what things you have in the group, but you know where they are in the group. And we're going to see some examples of what those might mean, but I think you can imagine some of those situations on your own. There's a notation for calculating permutations because these are so common. You've probably seen and used them on your calculator. This is the permutation notation, or NPR. And as using factorials, this is n factorial divided by n minus r factorial. What this works out to be is simply starting at n and multiplying by every number below it until you get to a certain point, which is one number bigger than n minus r, which works out to be n minus r plus 1. Factorial, not factorial, n minus r plus 1. Or if you distribute this minus sign, it's n minus 1, n minus 2, dot, 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 n minus r minus 1. It amounts to starting at n in the number of these terms in a row here is works out to be exactly r of these. So we're going to use this notation in conjunction with trying to the fundamental counting principle to try to decide how many different arrangements are there given some different situations. So we'll start with a fairly classic one involving, in this case, alphabet blocks. There's 5 different blocks, A, B, C, D, and E. You can tell the difference between each of them, meaning if you put them, no matter what arrangement you put them in, you can always tell what order they're in. So how many different permutations could you have? I like to think of problems like this as I have 5, as like I like to draw a picture of the number of like slots that I could put things. Then I'm going to write down how many choices I have at each of these slots. So to pick the first block, I think there are 5 blocks, so I could pick any one of those 5 blocks to go in the first spot. Once I've picked that, then there are 4 choices left, so any 4 of the remaining blocks to go there, then 3, then 2, then there's only 1 choice left in the end. In permutation notation, this would be like 5 blocks, and I'm going to arrange all 5 of them. That works out to be, even in factorial notation, n factorial over 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial, and we defined 0 factorial to be 1. So this is 1. So this is just 5 factorial, which is 120. Vary the question slightly. How many permutations end in the letter C? So if I look at, again, a picture of all the arrangements, this time I'm going to fix C in the last spot, meaning I'm forcing a C to be here. There's only 1 choice for the last spot, and it's C. So what do I have left? Well, now there's only 4 blocks to put in the first one. Once I've chosen that, there's 3 blocks, then 2, then 1. And then there's only 1 choice for C because it's C. So this is 4 times 3 times 2 times 1, which is 4 factorial. And we saw it, that's 24. How many permutations have this form? Again, same line of thinking as before. If I'm forcing A and forcing B into these two spots, then that only leaves 3 choices for this spot, 2 choices for the middle, and 1 choice for the last. And there's only 1 choice for A because there's only one A, and there's only 1 choice for B. And we'll end with this example: how many begin and also end with a vowel? So again, if I think of my slots, how many choices do I? Let's look at the vowels, and then we'll look at the consonants in the middle. Consonants. I think there are 2 choices for the vowels, either A or E. And then once I've picked the one to start, then it forces the last one to be the other vowel. Same game with the consonants. There are 3 consonants to choose from, B, C, and D. Then once I've chosen that, there's 2, and when I've chosen that, there's only 1 left. So I think in this arrangement where we start and end with a vowel, and there's 3 consonants in the middle, there's 2 times 3 times 2 times 1, which is 12 ways. So again, thinking about the situation, I'm drawing a picture. Even if your picture is just a bunch of lines with some where you're going to write numbers above, that can be really helpful. Here's another example. I have 6 different books. I'm going to arrange them in a row on a shelf. In how many ways can 2 of the books, say book A and book B, be together? So kind of a key word here is arranged, meaning you can tell the difference between all the books. There's no like repeated books. They all have a distinct cover, so you can tell what they are. And there's 6 of them. And we're going to think of how many ways can I arrange these things so that I'm going to force A and B to be next door to each other. So on the surface, that might seem maybe a tall task to do. Maybe we approach it in a similar way to we did above, where we have 6 books, so 4, 5, 6. So I have 6 spots. But I'm only considering the situations where A and B are next door to each other. So like A can't be at the beginning and then B at the end, or anywhere in the middle. What that forces is, because of this condition where A and B are next door to each other, that really kind of forces them to act as one book, because they have to be next to each other. So because of this condition, this is really more like having only 5 spots to work with, because A and B have to occupy one of these spots, either here, or maybe this one, or this one, or this one, or that one. So so maybe if we consider this as A and B being one unit, then I think there are 5 choices for any of those books to be here. Then there are 4, then 3, then 2, then 1. Once I know this arrangement, this would be the number of ways that A and B are working together. For every one of these, though, I could either have A first and B second, or I could have B first then A second. So this is the ways to arrange these books together. And then for every one of these, there's a partner where A and B are flip-flopped. So I think that there are 5 times 4 times 3 times 2 times 1 ways to arrange the books together. And then there are 2 ways to flip-flop A and B. This is ways. Arrange the 5. I'll use 5 in quotes, because one of those is A and B stuck together. And this works out to be 240 arrangements.